I don't see you online on the live board yet. We start this. Yeah. I think you missed the last orbital, the 3p. So for sulfur, what is the atomic number of sulfur? $60. Okay. So sulfur has 60 electrons. 16. So it has 16 electrons. It says here the longhand electron configuration. So we use the AFPAO. We follow that one. I think the one you wrote is correct except for the p orbital. So this is 1s, 2s, 2p, 3s, 3p. Right, and it sulfur has 16 electrons, so 2, 4, and then plus 6, 10, 12, 16. So the 3p orbital has 4 electrons. So this is the longhand electron configuration of sulfur. What did you write here? What did you type? You were on the right track, but what happened to your 3p? Yeah, you missed the 4. You typed something else. What did you type there? Okay, so let's move on to iodine. No questions on sulfur. Okay, it says here iodine, and you write the ion symbol of iodine. Okay, iodine. Iodine symbol is I, right? So what is the charge of iodine ion? Is it positive or negative? Yeah, it's -1. And then the number of electrons of iodine. This is atomic number is 53, right? So 53 electrons. Okay, so notice here that the charge of iodine is negative. So that means iodine gains 1 electron because it forms a negative ion. Okay, what is the noble gas before iodine? The noble gas closest to iodine, just before it. Xenon, from the periodic table. Okay, so it's xenon, the noble gas. So let's write the longhand electron configuration first for iodine. We have 1s, 2s, 2p, 3s, 3p, 4s. Next is 3d, right? 4p, 5s, 4d. So that's 53. That's a lot. So 2, 2, 6, that's 10, 12, 6, 14, 16, 10, 26, 32, 34, 44. So we still have 4D, 5P. Okay. Did we miss something? 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P, 5S, 4D, 5P. So how many electrons in all here? 10 plus 10, 20, plus 10, 30, 40, 48. 53 minus 48, it's 5. Right? So that would be 5p5 for the 5p orbital. Now this is the longhand, and we write on the shorthand. Now, okay, you said xenon is the, what's this? The noble gas just right before iodine. It's krypton. It's right before. It should be krypton. Yeah, I wonder why it says here the noble gas symbol xenon. All right. Okay, now I understand from your paper. The noble gas symbol xenon, that one is correct because that is after that is for the iodine ion, not for iodine. So for the longhand, this one is for the longhand, right? For the shorthand, we will erase xenon first. So for the shorthand electron configuration, the noble gas right before iodine is krypton. It's not xenon. All right, krypton. So what is the atomic number, or how many electrons does krypton have? Yeah, 36, right? So 36, we subtract 53 minus 36. So how many electrons will be left? 17. So we will crush out the 36 electrons, and we will only copy the 17 electrons. So we have from here, from the last orbitals, 5 plus 10 is 15, 16, 17. So we will only copy this one. So that is 5s2, 4d10, 5p5. So this is now the shorthand electron configuration of iodine, the neutral iodine. But we are asked for the shorthand configuration of iodine ion, right? So the iodine ion, take note here that iodine has a negative charge, -1. So that means it gains 1 electron. So we add 1 electron here to the last orbital. All right, so this would become krypton 5s2, 4d10, 5p6. So this is now the electron configuration of iodine ion. And now for the question noble gas symbol, why xenon is correct? Because if we expand the if we add 1 electron to the longhand electron configuration of iodine, we add here +1. The original number of electrons of iodine is 54, right? And then we add 53, and we add 1, it will become 54. And 54 is the number of electrons of xenon, as well as its atomic number. So that's why the answer there is xenon. You understand? Yeah, a bit confusing, right? Okay, so we're given, let me explain again. So we are asked for the shorthand electron configuration of iodine ion. But before doing that, we need to write the longhand electron configuration of iodine first. Okay, so before writing the longhand electron configuration of iodine, we need to know its atomic number, and it's 53. So that means it has 53 electrons. All right, and now we need to figure out the symbol of iodine, iodine ion, or the charge of iodine ion. The charge is -1, so we wrote I -1 here. All right, so the charge is negative, so that means iodine ion gains 1 electron. So that means we add electron to its original number of electrons. So we add here +1. So that would become 54 electrons in all, but we will just do it later. So we will write the longhand electron configuration, this one, first of the iodine and the neutral iodine. So this is now the longhand electron configuration. And then we write the shorthand. Now to write the shorthand electron configuration, we look for the closest noble gas right before the element. So the closest to iodine is krypton, right? And krypton, that's why we wrote krypton here in bracket. And krypton has 36 electrons. So we just subtract 36 from 53. We're left with 17 electrons. So this 17 electrons, that's the only number of electrons that we will copy here, because krypton replaces the number of electrons from 1s2 to here. Okay, this one, if you're going to add the electrons here, 2 plus 2 plus 6, that's 10, 18, 19, 20, 30, 36, right? So the number of electrons here in this one, this is actually the electron configuration of krypton. So instead of writing all of this, we just replace that with krypton, this one, and then we copy the rest of the electron configuration. So we copied 5s2, this one, 4d10, and 5p5. So we have 17 electrons left. So that is the shorthand electron configuration of the neutral iodine. But now we need to write the shorthand electron configuration of iodine ion. Iodine ion has a charge of -1, so again it gains an electron. So that means we add 1 electron to the original number of electrons, which is 53. So we add 1 here. That's why we added 1 here. Okay, so the shorthand notation would become 5s2, 4d10, 5p6 instead of 5p5. You got that? Yes. So this is the number of electrons of iodine, this one, and this one is the number of electrons of krypton. You got it now? All right. So let's move on to the next problem. Atom, bromine, magnesium, sulfur, that one. Okay. So let's start with that one. What are the numberings here? Like you write the symbol first. Let me just upload that. All right, can you see that? Okay, electron configuration with ions. Use the concept of full shell stability to predict the ions that would form from the following atoms. Then name the isoelectronic noble gas. So isoelectronic noble gas will be the noble gas after we add or subtract electrons. Okay, because we will be dealing with ions. And give the shorthand electron configuration for the ion. All right. For bromine, Let's answer all of this first. The symbols. So ion symbol, the atom is bromine, so they will become bromide, right? So that would be, what is the charge of bromide? Br -1. Then magnesium +2. Right? Then sulfur. Sulfur is sulfide ion, so S-2. Then aluminum. What is the charge of aluminum? Aluminum is a cation. Aluminum +3. Okay. And then what's next? Sodium. What is the charge of sodium? +1. All right. Then boron +3. Okay, so boron +3. Then the next one is calcium. What is the charge of calcium? Is it +1 or +2? It's +2. Yes, +2. Okay. What is the closest noble gas to... Okay, let's find out first the number of electrons, or atomic number of boron. What is the atomic number of boron? I know, bromine. Sorry. Bromine. 35. Yeah, 35. Then +1, because it's negative. The ion is +1, right? So +1, so that is 36, the number of electrons for the ion. So what is this ion? What is the noble gas with 36? Huh? Krypton, right? Wow. No, we won't write. Okay, I'm confused here for the noble gas part. If we write the noble gas of the ion after or before. That's what I'm confused about. So we will just write here krypton. Okay, we will just follow that problem, problem we previously solved, worked on. The, what's this? Iodine. All right, so we'll just write krypton there because we already added 1 electron. So but the shorthand, we will use the what's this? The noble gas right before bromine. So what is that noble gas before bromine? Argon. Okay, what is the atomic number of argon? How many electrons does argon have? -18. So 35 minus 18, or 36 minus 18, it's 18, right? So we will start with 3d10, then 4s, 4p. So for S2, 12 plus 6, 18. So that is the shorthand electron configuration of bromide ion, a bromine ion, or what we call bromide. The rest of the electron configuration And this is supposed to be 5, but then we are writing the configuration of bromide, the ion, so we add 1 here, that's why it's 6. Yeah, and then from there we figured out that the noble gas is krypton. Got that? Okay, so for magnesium is a cation, so the charge is +2, so that means it loses 2 electrons from the outermost orbital. So we subtract. So what is the atomic number of magnesium? 12. Okay, so 12 minus 2, it has 10 electrons, right? 10 electrons. So what is the noble gas? That has 10 electrons? Neon. Okay, so that is neon. The answer should be neon. And then we write the shorthand electron configuration of magnesium ion. So this is different because it has a positive charge. So we will use neon. We will use neon here because neon is also the noble gas right before magnesium. And it also happens that neon is the noble gas when we subtract 2 electrons. Alright? So neon, okay, 10, 12 minus 2, so that would be 1s2, 2s2, 2p6, so that is already neon, and we subtract 2, so we will answer only neon. This is the only answer, neon only for the ion, because we subtract 2. It's supposed to be neon 3s2, right? But then magnesium has a charge of +2, so it loses electrons, so we subtract 2 here, it will become 3s only, right? 3s to the 0, so there will be 1, so we will be left with only neon. Alright, you got that? Okay, and for next is sulfur. How many electrons does sulfur have? 16. So originally it has 16, and then sulfur's ion is sulfide, -2, so it gains electrons, so we add 2, so the number of electrons in all is 18. 16 plus 2. Okay, so which noble gas formed from sulfur ion that has a argon? Okay, so it's argon. The answer here is argon. But what is the noble gas right before sulfur? That one we will use for the configuration. Neon. Okay, so we will use neon. So neon has 10 electrons, right? And then we have 18, so 18 minus 10 is 8, so we're left with 18. So our shorthand notation would become, okay, that is 1s2, 2s2, 2p6. We delete that, so we'll be left with neon 3s2, 3p4. No, 3p 6, right? Because we add electrons. We add 2 electrons. Yeah, supposedly 3p4 for the original electron configuration, but we add 2, that's why it's 6. Supposedly it's 3p4 and then we add 2, that's why it's 6. Okay, shall we move on to aluminum? Okay, how many electrons does aluminum have? 13. Okay, aluminum's ion is charge is +3, so that means it loses electrons. So how many electrons does aluminum have? 13 minus 3 is 10. Okay, you're right, 10 electrons. So what is the noble gas that has 10 electrons? Okay, neon. And then for writing the shorthand electron configuration of the ion, aluminum ion, what is the noble gas right before aluminum? Neon, right? So it's still neon. So neon has 10, so we can write its shorthand. So 1s2, 2s2, 3p6, that is 10, and then we subtract 3. Then okay, so the electron configuration of aluminum ion is equal to neon, so that's it only. So it only has 10 electrons. Okay, no questions on that? All right. Okay, then for sodium, how many electrons does sodium have? Or the atomic number? 10 from the periodic table. The original 11. Yeah, so it's 11. Then for the ion, it has a charge of +1, so we subtract 1 minus 1. So the number of electrons now for the ion is 10. So what is, okay, the noble gas that has 10 electrons is neon. So this is neon again, the noble gas. And what is the noble gas right before sodium? Isn't it neon again? So neon. So +1. Okay, hold on. So neon, and then we have 1 for sodium, 1s2, 2s2, 2p6, 3s1, right? So here we will only have 3s1. No, we subtract 1 because sodium has, so this is also equal to neon. The sodium ion is also equal to neon. Yeah. Actually, the shorthand notation of shorthand electron configuration of ion, we will base on the number of electrons after adding or subtracting the ions, the electrons of the ions. So we will use this one, these electrons, not the original number of electrons. All right. Okay, then next we have boron. What is the atomic number of boron? 5. So originally boron has 5 electrons, but the charge is plus 3. So that means it loses electrons. So 5 minus 3. So it only has 2 electrons. So what is the noble gas that has 2 electrons? Helium. So the answer is helium. And the noble gas right before boron? Okay, helium. What is the charge of helium? I know, right? You got that? So boron ion is just equivalent to helium. Then for calcium, how many electrons does calcium have? Okay, 20. That's the original number of electrons. And then the charge is plus 2, so that means it loses electrons. So minus 2. So this is just the number of electrons is 18. So what noble gas that has 18 electrons? Argon. So this is argon. And what is the noble gas right before calcium? Argon. Okay. What is the atomic number of argon again? 18. So the number of electrons is 18 and argon has 18 electrons. Then that means the shorthand electron configuration of calcium ion is just equal to argon. The last one is nitrogen. Yeah, nitrogen. What is the charge or the ion of nitrogen? Nitrogen. Is it nitride? So minus 3. So what is the number of electrons of nitrogen? No, the charge is negative, so that means it gains electrons. So plus 3. When it's positive, it's minus. So plus 3, it's 10. So what is the... Okay. Okay. So it should be neon here. I hope we are right here. Okay, neon. So that is the noble gas that is formed from 10 electrons. So what is the noble gas right before nitrogen? Helium. Now we will use that for the shorthand. Okay, so helium has 1s2. 1s2, but we have 10 electrons here. So 1s2, and we still have 2s2, 2p6. So this is now the shorthand electron configuration of nitrogen ion. Yeah, I hope you understood everything. Is that the last one? Have we answered everything? Yeah, we did. Any clarifications?